Hi, this is our advanced big data analytics project, uh, and the subject is predicting Amazon product review helpfulness. And we are the two team members, Drumal Parekh and Sahil Shah. So, e-commerce is a booming business, and more than $1 billion business, and user reviews are integral to e-commerce. We all read reviews before purchasing a product, both the good ones and the critical ones. So Amazon allows readers to mark whether a review is helpful or not, and these votes help in determining the order of reviews that is shown to a user. And we often see that a top review is quite old, often by more than a year, whereas latest reviews are not read by many people, and hence they might not have been marked helpful by a lot of people, and hence they won't show near the top of the reviews. Consider a sample product in the grocery and gourmet food department of Amazon. We now consider the following reviews for that product. As you can see, the top positive review has 125 people who found it helpful. But it was written in December 13, 2012, and hence it's quite old. Whereas a newer review written just a few days ago would not have been read by many people, and hence many people would not have voted upon it. And hence, even if that review is as helpful as a top review, it won't be seen anywhere in the top of the ordering, according to Amazon's current system. This is the dataset that we use, which has been obtained by Professor Julian Macaulay at University of California, San Diego, and we need permission for that. It is not publicly available. The dataset consists of product review and metadata from Amazon for the duration of July 1996 and May 2014. We use the review and product metadata from grocery and gourmet food department. The dataset is in the form of a compressed gzip file. It's in a JSON format, as you can see from these images. The data has about 1.3 million reviews for about 170,000 products. We only choose those reviews which have at least 10 votes for that review. That is, at least 10 people marked whether a review is helpful or not. As you can see in this image, 79 people voted upon the helpfulness of this review, and hence I would consider such reviews in our training data. We use the helpfulness parameter to calculate it factor as 1 if the ratio of number of helpful ratings to the number of ratings is greater than zero point 0.7, else it's labeled 0. That is, if 7 out of 10 people found a review helpful, we would mark its H factor as 1, and that is the target variable that we are trying to predict. We calculate the time of the first review of a product and use this to calculate the lateness of a review. For each product review, we calculate the number of reviews for the same product. These allow us to add more interesting features like the lateness would be an additional temporal feature for our training data. We process the review text in the following manner, wherein the review text and the summary text are tokenized to calculate the term frequencies using a count vectorizer. We calculate the word count of the review text and the summary text. We then split the data into two parts. The training data set is 80% and the remaining is for testing. This allows us to validate the performance of our various classification models. The splitting is done randomly and hence it's a quite accurate measure of performance. These are the features that we use. The overall product rating, basically, that is the number out of 5 that a user assigns to a product, and that's basically those 5 stars you see on an Amazon review. The lateness of a review, as we talked about, the number of reviews for the same product, the review text length, the summary text length, term frequencies of review and summary texts. These are the following classification models that we've used: multinomial naive, logistic regression, decision tree classifier, and gradient boosting classifier. Now, we use 4 different types of classifier to find a more accurate model for this dataset. We use these 4 models in order to evaluate their performances and to use the best classification system for our prediction project that we are building upon. And we implemented the project in Python, and we used the following modules like pandas, which is a data structure module which allows us to store our training dataset in a convenient data structure. Scikit-learn has been used to implement machine learning algorithms like the classification models that we talked about before. These are the results that we get. Now, accuracy score is the number of true positives that were accurately determined by our classification systems, whereas the precision score is the ratio of the number of true positives to the total number of true and false positives. Now, as you can see from these numbers, naive had the lowest accuracy score, whereas logistic regression had the lowest precision score. Gradient boosting outperformed all other classification algorithms. It had a 79% accuracy score and an 83% precision score. Gradient boosting also took more time than the other ones. It took around 2 or 3 minutes to train the data. So now we built a system that would allow a user to input the summary text, the overall rating, the review text, and the number of reviews for that product. All of which data is very easily available for every review on an Amazon website. So what our system would do is to process this using the dataset that we have, build a model using a dataset, and it would predict whether the review that the user wants to give is helpful or not according to the various classification models. Now, this review that you can see uh, on is right now is very marked helpful by all of our classification models, and this review has been dated November 23, 2014, which is not within our dataset, but we find that it is the top review for this product category, and hence it was classified as helpful by our system as well. So we found that logistic regression model gives the lowest precision score among all the models, while naive Bayes had the lowest accuracy. Gradient boosting classifier gave the best score for both metrics. This is an encouraging demonstration for showing that automated review systems can be, can be used to judge the helpfulness of a product review. In the future, we would like to derive more advanced features using syntactic and sentimental analysis of the review text. These would help in adding more complex features to the training dataset and might yield even greater precision and accuracy scores. We would like to extend the system to work for all product categories. These are our references. Thank you for listening.